Hi dear students, good evening. Today we are going to discuss CUET previous question discussion, that is second part of mechanics, right? So let us directly go to the questions. See, first question is, an insect of mass m crawls on the earth surface with a velocity v0 at phi angle north of east. The latitude of a place where insect is situated at lambda. If omega be the angular velocity of earth spinning motion and r is the radius of earth, then calculate the centrifugal force acting on the insect. See, we already studied, suppose here we have earth, right? So one insect, so northeast, this here one insect is crawling, right, like this. So it is rotating like this. So insect is crawling, so rotating means it has an angular velocity omega here, right? So at a latitude, suppose the insect, see what latitude it is, lambda is the latitude of the insect, right? So once lambda is the latitude means you know what is the perpendicular distance. See, this centrifugal force is m omega square r perpendicular, right? This is the centrifugal force, right? Now m omega square r perpendicular, what is r perpendicular? R perpendicular is, see this distance, this this is the perpendicular distance from the axis. See this triangle you see, so this is lambda. So if this is lambda means what about this angle? This angle is, right, if this angle is 90 minus lambda, right, this angle is 90 minus lambda. Now this r perpendicular, that is this distance only, r perpendicular, right? So this r perpendicular is, say this distance is radius, right? On the earth surface only it is this insect position. So from earth center to position, any point on the surface, that is radius only. So let me write this perpendicular distance as r cos, sorry, r sin 90 minus lambda, r sin 90 minus lambda, opposite side only this. So opposite side is hypotenuse into this sin 9. Sin 90 minus lambda is r cos lambda. So we may write this as r cos lambda. Then m omega square r cos lambda is the answer, right? So very simple question, m omega square r cos lambda, option A is correct, right? All right. Now let us go to another question. See, two wires of equal length and cross-sectional area are suspended as shown in the figure. Their Young's modulus are y1 and y2 respectively. The equivalent Young's modulus will be, so we need to calculate equivalent Young's modulus. See, one wire, see spring constant what, suppose a wire of length L, okay, with a weight it is there means y is equal to FL divided by A delta L. Now YA by L is equal to F divided by delta L only. Now compare to F is equal to Kx, that means K delta L. F is equal to Kx, that is the spring force, right? Then F by delta L is equal to K. So spring constant is F by delta L, that is spring constant. Now two wires, from the figure it is clear that, see from the figure, two wires are parallel, right? So two wires, so one wire is this, one wire is this. So its area is A, identical, equal, two wires of equal length and cross sectional area, material only different. So it has K1, it has K2. So y is equal to K, you can write as K1 plus K2. Two springs are connected in parallel, effective spring constant what? That is k1 plus k2. But by joining these two wires, you get a thick wire of area, double the radius, right? So two wires you join parallelly means net area is 2a. Then ya by l only. What is k value? Ya by l. So ya by l, k is equal to y. A is 2a by length is not changing by parallel connection, right? So L only. Here K1 Ya by, right, Y1 A divided by L plus Y2 A divided by L. Now A by L, A by L, A by L cancel. 2y is equal to y1 plus y2. So you may write y is equal to y1 plus y2 by 2. Right. Just you have to study theoretical section. We studied there what is Young's modulus, what is spring constant, everything we studied. Right. So option B is correct. Now let us go to another question. The ratio of length radii Young's moduli of a steel and brass wires, figures A, B, C are respectively. So ratio of length L steel by the ratio of steel and L steel by L brass, that is A, and next parameter is length radii R steel by R brass, that is given B. Now y steel divided by y brass, that is given C respectively. Then corresponding ratio of increase in their length. So here what is increasing length? Y is equal to FL divided by A delta L only. Then increasing delta L is equal to FL divided by AY. That is, we can write delta L steel divided by delta L brass is equal to, you can write F steel divided by F brass. Here L steel divided by L brass. Now area is you can write as pi r square, because this is a cylindrical wire only, brass wire only. So say this area is radius, area is A1, then pi rs see pi rs square steel, right, area down only, so brass go up 1 by area only, so 1 pi rb square divided by pi r steel square, right, a2 by a1. Now so I can, and into here y, then y brass divided by y steel. So these many quantities will come when you take the ratio. Now F steel, see the steel wire has to carry both this 2m and m. Then what is the force acting here? Mg plus 2mg, that is 3mg. So 3mg, but F brass wire carrying this 2mg only, because it is connected to this mass only. So this string carry this force 2mg only. Then we can write 2mg into ls by lb. Ls by lb they given, that is a, all right, and by rb by rs. Rs by rb they given, then rb by rs 1 by b square. Why? Because rb by rs the whole square. Now yb by y is equal to 1 by c square. Then mg cancel. Then what is the final pending answer? That is 3, right, 3a divided by 2b square c square, right. So sorry, here we need not yb by ys only, so 1 by c only required here, no square, because final term this is the formula, right. So yb by ys only, yb by 1 by c only. So 3 by 2a divided by b square c, 3a divided by 2b square c is the answer. So which is the option? 3a divided by 2b square c, option B is correct, right? All right. Now let us go to another question. The increase in length, right? The increase in length of a wire on stretching is 0.025 percentage. If its Poisson ratio is 0.4, then percentage of decrease in diameter is, see, what is Poisson ratio? Lateral strain by longitudinal strain. See, one wire is there. Once you put a mass here, so its length increase. That time what happen? Diameter decrease, length increasing time because of weight. So that decrease in diameter divided by that is a lateral strain. Lateral strain means a strain of diameter. Now longitudinal strain, that only Poisson ratio. That Poisson ratio they given 0.4, right? Increasing the length by stretching, so this many percentage. So delta d by d is divided by this, you can write as 0.025 percentage. Then delta d by d is equal to 0.4 into, right, 0.025 percentage. So this is definitely 4 into, that is 0.01 percentage come, right? 4 into 2500 only, right? So 0.01 percentage will come. All right. All right. Now let us go to another question. When a metal wire elongates by hanging a load on it, then the fractional change in volume is proportional to, right? So when a metal wire elongates means what I can say, we know metal wire elongates by hanging a load on it, then fractional change in volume is asking, right? So a wire has which shape? Cylindrical shape only. Then V is equal to pi r square L only. Then V delta V by V you can write as 2 times delta R by R plus delta L by L. Now we already seen Poisson ratio is lateral strain. So dr by delta R by R divided by delta L by L. Now delta R by you can write as delta V by V is equal to 2 times minus sigma into, right, delta L by L. Can I write it? So sigma into delta R by R plus delta L by L. This I can write as delta V by V is equal to, see, delta L by L I can take out. Then here what I have, 1 minus 2 sigma. Poisson ratio is a constant value. Then it is proportional to what? Delta L by L, change in volume percentage, that is proportional to delta L by L only, right? All right. Now let us go to another question. A person is standing at the edge of a disk of radius r. The disk is rotating about the axis with uniform angular velocity omega. The person throws a stone radially outward direction with a speed omega r by 2 relative for the disk. Calculate the acceleration of the stone as seen by the person soon after throwing. Okay, see, the situation is one disk is there, right? Now it is rotating also. Okay, so at the end one person is there. He is throwing one ball. Okay, horizontally throwing one ball. Now as he observe this ball, what is the resultant acceleration? On a moving frame, you throw something is, it is moving, so he is looking from a moving frame, right? So two kind of force acting on this. One is centripetal force, centrifugal force. Second one is minus 2m omega cross v. This we know, what is we studied, minus 2m into omega is in the direction of omega k cap, and v, the body is going in the high cap direction, then k cross I, that is j cap, k cross I is j cap, right? So we take this x, this is z, right? Then definitely this is j cap, then this is minus j cap, here one negative sign. So one, this is what, this is Coriolis force, this is centrifugal force. So centrifugal force acting away from the circular path. So this is rotating like this, so away radially outward from the circular path, that is centrifugal, and this is this j cap direction, minus j cap direction, that is F Coriolis force. Then what is the resultant force? Resultant force is two perpendicular forces are acting, then resultant force is Fc square plus F Coriolis square. Then this you know, m omega square r whole square plus F Coriolis what, 2m omega v the whole square, 2m omega cross v. Now here we can take some terms we can take out, right? See here, m omega square is there, but they given omega r by 2 with the speed is omega r by 2, then root of m omega square r. So let me expand this m square omega raised to 4 r square here. Now let me erase this all. Here see, here 4m square, this v I am giving, see v they given in the question omega r by 2, then v I can replace with omega r by 2. See I can give capital R only here and all, here capital R, so here capital R, so this is r square, 4m square omega r by 2 the whole square. Then this 2 cancel, here what I can say, m square omega square, right, r square, that is m square omega square whole square, that is what, omega raised to 4 r square, this root, that is you can write this is 2 times m square omega raised to 4 r square, that is root 2 m omega square r, right? This is the net force. Now what is acceleration? Acceleration is equal to, you find root 2 omega square r is equal to F by m. Force per mass is acceleration, right? Then root 2 omega square r, option C is correct, right? All right. Now let us go to another question. The question is, a metallic sphere of mass m falls through a glycerin with a terminal velocity v. If you drop a ball of mass item of same metal into the glycerin, terminal velocity is, fluid mechanics terminal velocity equation be 2 by 9 eta r square g is rho minus sigma. This formula we derived, right? So Vt is proportional to what, r square only. In first case, mass density is equal to mass per volume, right? Then mass is equal to density into, first case say radius is r, so mass is 4 by 3 pi r cube. Now if it is 80m means what I can write, new mass, that is 8 times 80m, 4 by 3 pi r cube, r dash cube, then that is 2 r dash the whole cube, then 4 by 3 pi 2 r dash the whole cube we can write it, right? So second case, we cannot give r dash, you can give r because this mass 8 times only, so here that volume only we know. So 4 by 3 4 by 3 pi 2r the whole cube you can write. Then second case Vt by Vt dash is proportional to here 2r the whole square come. Then Vt dash by V is equal to 4 come. Then Vt is equal to 4V. Then option B is correct, right? Alright. Now let us go to another question. A cylindrical vessel is filled with water up to a height h. A hole is bored the wall at a depth h from the free surface of the water. For maximum range h is equal to, see, one tank is there, it is filled with water. Okay, so filled with the water. Now up to a height h, up to h height we have water. Now you are putting a hole here at a distance h, then water come out. Then what is the range? Range means from the cylinder base, tank base, what distance water falling, that only range. What is that range? Suppose here with the velocity v coming means this horizontal distance is equal to that only range, r is equal to horizontal velocity into time taken to reach here, that only Vt only distance, time of taken. But if it falls this much height, what is that height? Here only hole putting h minus h. Then velocity into what is the time, that range is equal to what is the height, time of flight, right? So range what we have to find, that is first we have to find the range. Okay, the time taken is root 2h by g, time taken to fall something from a height, that is root 2h by g only, right? Now that is root 2 into h minus h divided by g, and horizontal velocity of the water attained, that also what we studied, from a height h water is coming, what is the velocity? Root 2 gh. Then by simplifying this you get a range. What is range formula? Range is equal to root 2 to 4, then 2 come out, you can g you can cancel, then h into h minus h, this is the range, right? Now if this range is maximum, differential of dh by dh of r square we can take, that should be 0. Why r square taking means in order to remove this square root, that means d by dh of, see, 4 time hh minus h square equal to 0. Okay, that means that equal to 0 means you can differentiate this 4 is 0. By differentiating h, this 4 you can take and bring down 0. Then dh by h1 capital H you can take out, and differentiation of h square, that is 2h equal to 0. Then h is equal to 2h, then h is equal to h by 2, right? So option B is correct, right? All right. Now let us go to another question. A drop of liquid of diameter 2.8 millimeter breaks up into 125 identical drop. The change in energy nearly, right? That is the question. So here we know energy is equal to when a drop is breaking, energy liberated is equal to surface tension into change in area. Now initial area, what? A drop of liquid, see, initial area say 4 pi r square, this is a big drop. Now it is split into 125 drops. Then one small drops area 4 pi r square, like that 125 drops are there. Then 125 into 4 pi small r square, right? But r and r connecting relation, initially the volume you equate 4 by 3 pi r cube, only converting into 125 into 4 by 3 pi small r cube. Then you can get a small r is equal to capital R by 5. Okay, here they given diameter. Then this is a 1.4 only radius. Then 1.4 divided by 5 only small radius. So small radius is equal to 1.4 into 10 raised to minus 3 divided by 5. Small r we calculated. Now what is change in area? Delta E is equal to surface tension they given 75 into 10 raised to 9 means 10 raised to minus 5, here 10 raised to minus 2 centimeter, right, into change in area is, what is the change in area? Final area minus initial area. Finally 125 drops are there into 4 pi r square, but r is equal to r by 5 the whole square, right, minus initial area is 4 pi r square. Now let me take 75 into 10 raised to minus 3, and here 5 square 25, right, 4 pi r square you can take out, 4 pi r is given, that is 1.4 into 10 raised to minus 3, that is the diameter, then this whole square that I taken out. Here what is remaining? See, this 25 divided by 125, that is 5, here minus 1, that is 4. By doing this you get a 74 into 10 raised to minus 7 joule. This is approximately 74 into 10 raised to minus 7 joule is 1 erg, right, erg. Okay, so 10 raised to minus 7 joule, okay, that we can write as 1 erg, right. So to 74 erg is the answer. All right, now let us go to another question. A bud of mass m lies at the center of a thin wire of length L, then it is rotated with a uniform angular velocity omega about its one end, due to which the bed slides away from the axis of rotation. Find the velocity of the bed with respect to the rod at the moment when the bed is about to leave the free end of the wire. So here what given is, look here, one rotating mass, right, a wire of length is there, a wire of length is there. Now a bud is uniformly, that is actually m lies at the center of the wire. Now this wire is going to rotate. See, this is along this axis with omega it is going to rotate. Then at the middle means the wire length is L, this is L. Okay, now at middle. Now when this bud, see, by rotation due to centrifugal force, this bud is moving away. At the time it is leaving from the surface of the bud, that time we want to calculate the velocity of the bud, right? So what is the work done? Actually force into, because of work done only, this by centrifugal force some work is done, due to that work only it will be moving, right? So we can write that work is equal to integral FDR, basic expression. Now W is equal to integral, but length is varying from L by 2 to L. So okay, L by 2 to L. What is centrifugal force? M omega square R dr. Am I right? M omega square R dr. All right. So that is the centrifugal force. Now what is work done? Work done is, suppose starting with a velocity v. Okay, starting with a velocity 0 and finally say it has a velocity v. What is work done? Change in kinetic energy. That only work energy theorem says, right? So change in kinetic energy half mv square minus initial kinetic energy is 0. By integrating this m omega square, you can take out r square by 2. R square by 2 limit is L by 2 to L. So this m you can v square is equal to 2 omega. Oh, this 2 and okay, that 2 and this 2 also cancel. Okay, this 2, this 2. Then v square is equal to, you can write this as L square minus L square by 4. Then v square is equal to 3 by 4 L square. Then v is equal to some omega square we have here. Then omega square. Then v is equal to root 3 by 2 L omega. Then which is the option? Option B is correct, right? All right. Now let us go to another question. Copper is fixed volume. Copper of fixed volume. V is drawn into wire of length L. So we may write this as L. When the wire is subjected to a constant force F, the extension produced in the wire is delta L. Which of the following graph is a straight line? Okay. So copper wire fixed volume. Volume is fixed into. Then the extension produced in the wire is delta L. Then following graph is a straight line. So just what is delta L? So let me write this Young's modulus is equal to FL divided by A delta L. Then delta L is equal to FL divided by AY. Now extension produced is proportional to what should be volume is a constant they given. This volume suppose a wire elongate also. Suppose it is elongated like this, then volume not change. So let me write L here and L here. Area into length below I can give that is F divided by this force constant already they informed. Then constant force area into L volume. Then here L square. Young's modulus of material is always a constant, a particular material. So this is a constant. And then delta L is proportional to L square only. So that produces a straight line. So delta L versus L square only straight line. Understood? So delta L and L square producing straight line. Now we have another question here. A certain number of spherical drops. All right. A certain number of spherical drops of liquid radius R coalesce to form a single drop of radius R with the volume V and T is the surface tension. Then energy what? Energy before we seen energy is equal to what? Surface tension into change in area. Now surface tension into change in area what? N into C. Certain number of N drops joining together to form a big drop of radius R. Here radius you may take small r. Then what is volume equate means this side volume equal to that side volume. 4 by 3 pi r cube N drops equal to 4 by 3 pi capital R cube. By solving this capital R you get N raised to 1 by 3 into small r. Alright, N raised to 1 by 3 into small r. So here change in area only. Initially N into 4 pi r square minus finally 4 pi capital R square. This is the change in area. That is T into. So N raised to 1 by 3 r you can put, then you can take 4 pi r square out. Then here N, right. N you can 4 pi r square you taking out means, we can take 4 pi capital R square we can take out. Why? Because 4 pi capital R, because final big volume, because final volume is V, right, of radius capital R only. So 4 pi r square you taking out means here no 4 pi capital R square. So you write what you write here we write n into 4 pi r square we taken out, right. Then r square is there, you have to divide it with r square minus 1. Am I right? All right. Okay. Now we need say I am writing 4 by 3 pi r square. So E is equal to T into, can I write this as by multiplying 3 here, I can write 4 by 3 here. Pi, here r cube I need. So r cube divided by r we write. Am I right? Okay. Then n into r square by r square minus 1. This 4 by 3 pi r cube you may write as, see, this 4 by 3 pi r cube you can write as, what you can write? That is, now let us proceed. So for me just erase this. Okay. See, look here. Now by writing this energy is equal to 3 T into 4 by 3 pi r cube is the final volume of the drop we given here. Okay, now remaining I am multiplying to bracket, that is n r square divided by this 1 by r I am multiplying r cube minus 1 by r. Now you can write as 3Vt. This r cube, you know capital R is equal to n raised to 1 by 3 r. If that you give means what come here? Sorry, small r. Okay. So it is come as, right, n into r square divided by n raised to 1 by 3 r the whole cube, that is n into, right, r cube minus 1 by r. Am I right? All right. So 1 by r square, right? So this n cancel, this r cube. So 3Vt into 1 by r minus 1 by r. This much energy release only, right? All right. Now to breaking. So breaking time energy release. Joining time we have to give energy to them. Okay. So all right. Now let us go to another question. The bulk modulus of a spherical object is B. If it is subjected to uniform pressure P, then fractional decrease in its radius. So a bulk modulus of spherical object, see, bulk modulus we know P divided by delta V by V. Now volume of a spherical object 4 by 3 pi r cube, then delta V by V is equal to 3 delta R by R, that you substitute here, B is equal to P divided by 3 delta R by R, then delta R by R is equal to P by 3B. This is only fractional decreasing in radius, right, P by 3B, right. All right. Now let us go to another question. That is the last question, right. See, the question is, a particle of mass m moves radially outward with a constant velocity v0 in a turntable rotating with a uniform angular velocity omega. The coefficient of friction is, see, two kind of forces acting, right. Suppose a rotating table, it is rotating like this. Now one body moving like this means, one body moving with a velocity v, there are two forces acting on it. One is away centrifugal force, another force 2m omega cross v. That means this is omega direction, this is the velocity direction. Perpendicular to that, another Coriolis force, that is Coriolis, F Coriolis, this is centrifugal. Now here this direction F Coriolis force acting. We studied theoretical discussion, right? So what is the resultant force in between these two perpendicular forces? What is resultant force? Square root of centrifugal force is a m omega square r whole square, am I right, plus 2m omega v the whole square, that is Coriolis force, right? Now 2m omega v is there, v0 is this v and all they given v. Now let me take this f is there. Now what and all you can take out here? See, let me simplify this first. Then m omega square, see, m square omega raised to 4 r square plus 4 m, right? Here you can think about this velocity v, right? What is this velocity? This velocity is we can write as, so 4 m square, right, 4 m square omega square v square. Now you can take f is equal to what? See, this force, it is going with this ball going with the constant velocity, means there is no force acting on it. That means force is acting but opposite frictional force is there on the surface. Then what is frictional force? Mu mg, right? So f I am replacing with mu mg, right? Now you can take a common out, then mu mg equal to, right, mu mg into, right, so let me take a pen, all right, mu mg into, all right, okay, mu mg into, here you can take out m, right, m you can take out, maybe you can take omega v0 also, omega v0 v also you can take out. If we take means you can write as here square root of, here nothing remaining, right, only 4 only remaining, 4 plus, but here omega raised to 4 is there, so we have to write here there is no v, we have to divide also, and the extra one r square is there, then you have to write omega square r square divided by v square, right? Then m you can cancel, then mu is equal to r omega by g, right? We can write omega v by g root 4 plus omega r by v the whole square. Then which is the option come? Option A is correct, right? All right. So this all about this section. Now let us go to another paper tomorrow. So mechanics part CUET paper discussion here we completed. Thank you.